Hi my dear friends, this is your Rashekar from our SAIMEDHA coaching center. I think everyone started your preparation. KPTCL, JE as well as AE aspirants, be ready for preparation. Don't waste your time. Examination will be soon. In that purpose, I came here to explain previous junior engineer question paper. Previously 2011 and 2014 junior engineer question papers are there. In that 2011 junior engineer question paper explanation is going on now. Let's see how they are asking questions. Based on that, how we have to prepare for our junior engineer. This session especially for junior engineers, it's previous question paper explanation. Okay guys? Right sir. Let's see here. Now we are going to discuss about junior engineer previous question paper on KPTCL. This is my first question. What is my first question? A simple three-phase generator. This is a three-phase generator. Consists of three conductive loops separated by. This is a three-phase generator. That three-phase generator consists of three conductive loops separated by. Nothing but generally we know that three-phase system. R phase and B phase or Y phase, B phase, R, Y, B phases, three phases. Each phase generally separated by 120 degrees. We know already this thing already. So the same criteria will take place whatever the three phase system. So here also what they given, a three phase generator consists of three conductive loops of course, that each loop should be separated by how much angle? How much angle? Option A they given 60 degrees, 120 degrees, 180 degrees or 360 degrees. Which is correct answer? Very simple question sir. The correct answer is 120 degrees. Always this is separated by 120 degrees only. This is the first question. Very simple question. Let's go for second question. Yeah, this is the second question. This is very important. Even now we can expect like a questions in our 2022 junior engineer examination. Let's see, the armature in a electrical machine is. The armature in a electrical machine is. Option A, always stator. Option B, always a rotor. Option C, either a stator or a rotor. Option D, always a stator in motor and rotor in a generator. Which answer is correct? Give me answer first. Give me in comments. I am waiting for your answer. Tell me sir. So what is the question? See again. The armature in a electrical machine. First of all, what is armature? Armature or armature winding is nothing but the winding which produces the EMF. The winding which produces the EMF is called armature winding. Field winding, for example, what is field winding? The winding which will produce the magnetic field or magnetic flux. The winding which will produce the magnetic field or magnetic flux is called field winding. The winding which will produce the EMF is called armature winding. Now the question is armature winding in the electrical machine. Generally we have a DC machine as well as a synchronous machine. In DC machine, the armature is a rotor. In synchronous machine, the armature is a stator. In synchronous machine, armature, stationary armature is more preferable. In DC machine, rotating armature is more preferable. Sir, why the rotating armature only preferable in DC machine? For example, I am using my DC generator. DC generator, right? This is a DC generator. Whatever the generator, it will produce the EMF is called AC. It may be AC generator or DC generator. Actually, the EMF produced in the armature winding is AC. But what is the output of DC generator? The output of DC generator should be DC. Of course, generated is AC, but the output is DC. How? What happens inside? Commutation happens. That commutation is done by the commutator. Here, commutator is the heart of the DC machine. It will convert AC to DC in the generator. It converts DC to AC in motor. Okay, so commutator is a rotating device. This is a dynamical device. If you want this conversion, we must take the armature also rotor. If the armature is stator, the commutator will not work out. If there is no commutator action, there is no DC machine. Yes or no, guys? Yes? If you want commutation action, we must take armature on the rotor. Then, what about synchronous machine? In synchronous machine, for example, synchronous generator, the produced is AC, of course the output also AC, no need of commutation. No need of commutation. If no need of commutation, we can place our armature winding in stator. Of course, in some synchronous machine, armature winding also placed on rotor. Which type of machines? Low rating machines. In low rating machines, rotating armatures also is there. But for high rating machines, stationary armature more preferable. Why? Because I will give you, we have many reasons. Why the armature winding placed on stator in synchronous machine? Easy collection of current, easy insulation, easy balancing of forces, less voltage regulation, less leakage flux. Like that, many advantages are there with stationary armature in synchronous machine. So finally, what is our answer, sir? So finally, the answer is C, either a stator or a rotor. Where it is stator? In synchronous machine, it is a stator. In DC machine, the armature is a rotor. Okay, sir? Are you clear? Nice, sir. Very good. Let's go for next question. So, like this, you have to prepare. Okay, they may ask you any question from this. You can do the answer. So, your preparation should be like this. If you prepare like this, whatever he asks you question, you can get the answer easily. Okay, we will give you complete knowledge about your examination schedule, your examination syllabus. Don't bother about that. Just prepare well. Just follow our classes, video classes or offline classes, whatever. Just follow them. Then you can get the job. Just do hard work. Just 2 to 3 months. Prepare well. You will be in government job. Right, sir? Let's go for next question. Next question. So this is my third question. See here. What is the frequency of an alternator? What is the frequency of an alternator which makes 3000 revolutions per minute? 3000 revolutions per minute and has 2 magnetic poles, 2 poles. What they given, sir? They given the speed. They given speed 3000 revolution per minute. Nothing but RPM, sir. Okay, so n is equals to 3000 rpm and number of poles they given 2 number of poles, but I want the frequency. I want the frequency. How we can get? Yeah, this is a basic principle in induction machine and synchronous machine. The speed ns is equals to 120 f by p. What is ns? ns is the 3000 is equals to 120 into we don't know the frequency. 120 into f by number of poles is the 2. Number of poles is the 2. So simply 2 ones 260s are 2 ones 260s are. So what we have here, 3000 is equals to 60 into 50. Yes, so 0 0 gets cancelled, 6 ones are 6 5s are and 0. So the frequency is 50 Hz. What is the frequency here in my question? The frequency is 50 Hz. So frequency is 50 Hz. So this is the formula which is very important. Ns is equal to 120 f by p. For 50 Hz, if we are using 2 number of poles, its synchronous speed is 3000 rpm. If we are using 4 number of poles, this is 50, this is 4, then you will get 1500 rpm. Nothing but here, if number of poles double, then synchronous speed halved. If the number of poles doubled, then synchronous speed halved. For example, P is equals to 6. I used the number of poles 6. See here, for 2 poles 3000. Then number of poles increased by 3 times. Number of poles increased by 3 times. Then synchronous speed should reduced by 3 times. So the answer is 1000 rpm. Or you can place here 120 into 50 by 6. 120 into 50 by 6. You can get 1000 rpm. Like that, they will ask you questions on this. You have to do. This is a basic formula, sir. Okay, let's go for next question. Yeah, this is also one of the best question. You have to do this. See, what is the current flowing through A? What is the current flowing through A? 5.5 mega ohms. What is that? 5.5 mega ohms. Nothing but 5.5 into mega, nothing but 10 to the power of 6 ohms. 10 to the power of 6 ohms. Connected to a 220 volts voltage source. This is the voltage source they given. This is the resistance they given. Now I want to calculate current. So how we can? Current I is equals to, tell me, according to Ohm's law, the current directly proportional to V. From that, the current I is equals to V by R. What is V? V is the 220 by, this is 5.5 into 10 to the power of 6. Very simple, sir. What is the answer? 220 by 5.5 into, this is 1 by 10 to the power of 6. If you take this into numerator, what its value? 10 to the power of minus 6. If it is 10 to the power of 6, it is called as mega ohms. If it is 10 to the power of minus 6, it is called micro. This is called micro. So the answer should be in micro. This is amperes. This is mega amperes. This is microamperes. None of the above. So what is the answer? This is not correct. This is also not correct. This may be correct answer because in terms of microamperes. If this is also not correct, none of the above is correct. Yes or no, guys? Yes or no? Right, so tell me, what is the value? 220 by 5.5. 220 by 5.5 value? Yeah, 220 by 5.5 is equals to 40. Then option C is the correct answer. Very simple question. Within seconds you can do this answer if you have a practice. Right? Let's go for next question. Right. So what is this question? What is the resistance required to draw 4.8 milliamperes from a 6 volts source? What they given? This is the 6 volts battery, and he want 4.8 milliamperes of current. Then what is the resistance here we have to take? This is the question. I want this resistance. Very simple question. Yes or no? What is the resistance required to draw 4.8 milliamperes? Very simple. So tell me, actually V is equals to IR. From this I want the resistance R. R is equals to V by I. R is equals to V by I. So tell me, R is equals to V is the 6 upon 4.8 into milli. Milli nothing but 10 to the power of minus 3. Milli nothing but 10 to the power of minus 3. Now tell me what is answer. If this 10 to the power of minus 3 goes into numerator, 10 cube, minus 3 goes to plus 3. So 6 by 4.8. 6 by 4.8 nothing but this 6 by 4.8. 6 once, so actually it will not cut, that's why 0 point. This is 6 once, so 6 8s are 48. So 0.8, 1 by 0.8. 1 by 0.8 can be written as 10 by 8. 1 by 0.8 can be written as 10 by 8. 10 by 8 into 1000. 10 by 8 into 1000. 10 by 8 into 1000 how much? This is 1.25. 1.25. Is it okay? This is 8 by 10. So 10 by 8 into 1.8 goes 2 is there. 8 2s are 16. 4 is there. 8 5s are. So then what is the answer? This is not correct. So now tell me, this is or this is, which is correct answer? Exactly. Option B is the correct answer, because here 3 zeros are there. Already 2 is there. Next 0. Finally its value 1250 ohms. If this is 1250 ohms, then we can get a 4.8 milliamperes of current. Right, sir? Let's go for next question. Okay. Let's see this question. What should the increase in the voltage? From present to 12 volts? What is their present voltage? 12 volts. Now we have to increase the voltage. Why we have to increase the voltage? Once see here. If what they given? If you want to increase the amount of current. If you want to increase the amount of current in a resistor from 120 milliamperes to 240 milliamperes. See, this is a basic question in electrical. Actually, what is the basic law for electrical? Ohm's law, right? Okay. This is the application of Ohm's law. Okay, let's see what they given. Actually here 12 volts is there. Of course here some resistance is there. Actually here 120 milliamperes is flowing in this. Now I want to increase this voltage in order to flow the current of 240 milliamperes. So tell me, how much I have to increase the voltage? How much I have to increase the voltage? Very simple. According to Ohm's law, always the current is directly proportional to voltage. If voltage increases, current also increases. If the voltage double, then current also double. If the voltage increased by 10 times, then current also increased by 10 times. But here I want to increase the current double. So if you want to increase the current double, you have to increase the voltage double. So nothing but from 12 to 24 volts. From 12 to 24. We have to increase the 12 volts to 24 volts. But which of the following is correct answer? Can you tell me? Yeah, comment here. Comment here. The answer is 12 volts. Because what should the increase? What is the total voltage? They won't ask you like that. Here they didn't ask you what is the total voltage. What they ask you, what is the increase? How much we have to increase? From 12 to 24, how much we have to increase? 12 volts we have to increase. So we have to increase the 12 volts. If the 12 volts increases, nothing but total voltage 24. Nothing but voltage doubled. If the voltage doubled, then current also gets doubled. Like this. This is very simple question, sir. Like these questions they will ask you. Right? Let's go for next question. Let's go for next question. Yeah. Let's see. How many members you got this answer? Read the question and give me the answer in my comments. Give me the answer. First, I will see here. I will read the question. Given that magnetic flux in 0.2 meters square, sir, that is 0.2 meters square, because the given area. So given that the magnetic flux in 0.2 meters square is, the flux is 800 microwebers. 800 microwebers. What is the flux density? What is the flux density? I said you already, micro nothing but 10 to the power of minus 6. Okay, so tell me, what is flux density? What is flux density? Flux density is nothing but flux per unit area. Flux per unit area. So the flux density B is equals to flux. Flux is the 800 into 10 to the power of minus 6 Weber upon area 0.2 meter square. Weber per meter square is also called Tesla. Weber per meter square is also called Tesla. So what is the answer? This is micro, as usually micro. The answer should be micro, either this one or this one. This is wrong answer. So answer in terms of micro. Next, 800 by 0.2. What I said you, 800 by 0.2. How we can written as? This can be written as 8000 by 2, because here a point and one digit is there, right? So this can be written as 2 by 10. 0.2 can be written as 2 by 10. This 10 comes upside. So 8000 by 2 is the 4000. So this value 4000, this is micro. 4000 micro Tesla. Is there answer? This is also wrong answer. Of course, there is no micro. Here micro is there. So this is the correct answer. Flux density, they will ask you question. Very important, sir, flux density. Right, let's go for next question. Yeah, let's see. What is the SI unit for magnetic reluctance? This is a typical question. SI unit for magnetic reluctance. First of all, what is reluctance? Reluctance, what is reluctance? Generally this can be written as R or S, anyone. Reluctance nothing but, first of all, what is resistance? Resistance nothing but which oppose the flow of current. Reluctance nothing but which oppose the flow of flux. Which oppose the flow of flux. Yes. So reluctance nothing but which oppose the flow of flux. Then what is the formula for reluctance? Generally resistance R is equals to V by I. Resistance R is equal to V by I. Here V nothing but EMF by current. EMF by current. Then reluctance nothing but, if this is EMF by current, this is MMF by flux. This is MMF by flux. Here current will flow, here flux will flow. Here electromotive force we have to apply. Here magnetomotive force we have to apply. Here resistance, it opposes the current. Here reluctance, it opposes the flux. Everything same. Okay? Are you clear? Yes? So tell me, now what are the units? MMF nothing but number of turns into current, Ni. Flux nothing but phi, Ni by phi. Okay? Okay? Ni by phi. This is what? Number of turns, amperes. Ampere turns and flux is the Webers. So ampere turns per Weber is the answer. Ampere turns per Weber is the answer. That's very simple question. Of course, reluctance nothing but another units also is there. This is the SI units, ampere turns per Weber. Then what is the another units? The reluctance units are per Henry. This is also correct answer. Per Henry. How, sir? This is the basic reluctance. R is equals to L by mu A. L by mu A. L nothing but length. Mu nothing but Henry per meter. Area nothing but meter square. Meter into meter. This meter gets cancelled. 1 by Henry is the answer. This is also answer for reluctance. And this is also answer for reluctance, that is Weber per meter square. Now in my options, we have only one, ampere turns per Weber, ampere turns per Weber. It's clear, right? Let's go for next question. Tell me, sir, what is here? What is the inverse of reluctance? Very good question. Inverse of reluctance. Sir, what is the inverse of resistance? Inverse of resistance, conductance. Conductance bole to? Conductance nothing but allows the current. Reluctance nothing but oppose the flux. Then which will allows the flux? The inverse of reluctance is nothing but permeance. What is that? Permeance. Permeance nothing but 1 by reluctance. Remember this. Okay? Right. Here resistance, conductance. Reluctance, permeance. Reluctivity, permeability. Resistivity, conductivity. Resistance, conductance. Resistivity, conductivity. Reluctance, permeance. Reluctivity, permeability. Those are the inverse. reciprocal. Right, sir. Let's go for next question. Yeah, this is what coupling coefficient or coupling factor. We can call it as coupling factor. The coupling factor between two coils. For example, is there phi1 flux? Is there phi2 flux? Coupling factor, nothing but generally this phi1 may not completely links with this second coil. Some of the flux is losing here. Phi2, some of the phi2 is losing here, but something links with the first coil. Here, what is the coupling factor between these two? The coupling factor always between. It may not be 1. If coupling factor is equal to 1 means the total flux links with each other. If the coupling factor 0 means no flux links with each other. Then generally the coupling coefficient may not 1, may not 0, but in between 1 and 0. Its value should be in between 1 and 0. So which is the correct answer? 0 and 1 is the correct answer. Like these questions, they are asking very simple questions for you JE people. Okay? So don't late. Start your preparation. SAIMEDHA started online as well as offline. Online classes every day, morning 6 to 8 and evening 7 to 9, 4 hours per day. And offline classes, now we are planning for Saturday, Sunday government holidays in our Bangalore, Sheshadripuram, main road, first main road, beside HDFC Bank. Okay? Wish you very all the best. I will come again with the next set of questions in previous question paper. Okay? Thank you.